the recording. Good morning, everyone. I hope you are refreshed and yeah, because we have a very long weekend and I hope everyone is safe, free from any sickness and any harm. And let's start this week because this week is our module number 12. Now, by the way, this is your midterm exam week. Okay, for all the courses that you have, um, this will be your final exam. No, for other modular groups, like if you have modular group 2, this week will be your final exam week. However, for modular 4, yung courses na nagra-run all throughout the three modular groups, no? Kaya tinawag siyang modular 4. So this is our midterm week. Okay, so you'll be having your midterm exam, and the midterm exam nang ibibigay ko sa inyo is a skills exam. Okay? I will not give you a theoretical exam because uh, from time to time nag-online exam na naman kayo sa NetAcad. Okay? So we'll be doing the continuation of the topic about IP version 4 addressing and subnetting. So from the last topic that we discussed, so we talk about a lot of introduction on the IP addressing, and then we talk about segmentation of network. Okay, and that is done um, by following some steps, no, that are very very essential in subnetting a particular network. So we can subnet uh, our network using octet boundary. So when you say octet boundary, we are subnetting the network into the boundary of the octets that binds the IP addresses. Now, each octet corresponds to 8 bits, and the subnetting requires us to borrow or compute for the network addresses and the host addresses to be able to create a subnet. That's what you learned from the last week. And we did not finish this topic because it will take time to understand fully the IP addressing. I don't want to make this naman very very short topic to discuss. Now, last time we also discussed yung isang uh, network address that has a prefix of /8. It can be subnetted using /16. No? So that means if the prefix is very low, no, the more it has, uh, the more bigger the network is. No, the more bigger the network is, and the basic network that we associate, our home network, our office network, our class C network, and usually meron tayong /24 na subnet mask. Okay? So when you say /24, lahat ng first, second, and third octets are all ones except the fourth octet. No? The fourth octet resembles all of the uh, number of bits that will be considered as uh, the host portion of the network in a /24. So we also understood last time na the lower the prefix is, it can be divided into um, to smaller subnets. And as you can see, /8 can be subnetted using /16. It can also be subnetted using /24. Okay? And you can see an example here from the last time that we did show how to subnet the /8 into a /24 network. So dividing the /8 into into a subnet of a /24, it will allow us to give us the following addresses. However, we can subnet it into a more smaller network. For example, we can subnet it into /25, wherein we have two subnets created. /26, meaning we can create four subnets. /27, meaning we can create 8. /29, meaning we can create 16 subnets for that. And if you have /29, you can create 32 subnets. For /30, you can create 64 subnets. However, you will see na yung formula to get the number of hosts for each subnet, so you'll compute the number of unborrowed bits. No? So for example, here, 2 raised to 7, meaning 7 is the unborrowed bits. So that becomes 128 minus the broadcast address and the network address. That becomes 126. And so it goes until the end of the list. All right. So I showed you some video that will most probably simplify the explanation of getting of using the subnet mask and subnetting using the magic number. Yung magic number na tinutukoy natin is the 2 raised to 0, 2 raised to 1, 2 raised to 3, and so on, and so on. Okay? And I also gave you an activity last time, no? I haven't checked kung na-submit ko na siya o hindi. Whenever I have the time, I will try my best to check it. Okay, I think this is the last time that we stop on the conversation or in the discussion. So this is the sixth part of this chapter. So the title is to subnet a /16 and a /8 prefix. So how do we subnet that? So meaning itong mga /16 and /8 na to, first thing that you need to understand here ay napakalaki ng mga network na to, no? /8, /16. Ibig sabihin yung interval o yung mga number of hosts na pwede nating gamitin kapag ka ganito ang slash, napakalaki. No? Kasi 16 yung, pag sinabing 16, yung dalawang octet ang nasasakop niya na naka 1, di ba? So ang subnet mask niyan is 255.255.0.0. Alright? Now, yung unborrowed bits, no, na hindi kasama sa host sa network portion is also 2 raised to 16. And what is 2 raised to 16? Napakarami niyan. If you're going to compute that, that's around million of hosts that can be used in a /16. Ngayon, kung sa /16 million na, hindi lalo sa /8, di ba? Kung /8 mo ay prefix mo, kung yun ang prefix mo, /8, that means yung first octet mo lahat naka 1 yon, tapos yung tatlong remaining octets ay naka 0. So that's around 2 raised to 24. Di ba? Napakarami ng host na pwede mong ilagay, no? And I believe if you have a network like this, no, there are plenty of IP addresses that can be wasted. No? Ibig sabihin, hindi magagamit lahat. No? So, the purpose of subnetting is to not to waste a lot of IP addresses. Kaya itong /16, sinasubnet natin. Yung /8, sinasubnet natin. Kasi kung gagamitin mo lang tong slash na to, ang daming masasayang na IP addresses. So, yan yung concept ng segmentation. Aside from putting division on the big network, making it smaller, another possible benefit is that we can actually reduce the wastage of a lot of IP addresses. So moving on, as you can see from here, okay, the title is to create subnet with a /16 prefix, right? And you can see here the table highlights all the possible scenarios for subnetting as a /16 prefix. You can see from here, It's very small, so we might want to make it a little bit bigger, no? Yan, no? So from the illustration, we can see here that a slash 16 can be subnetted into how many? One, two, three. How many types or how many variation? No? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Now from slash 17 to slash 30, that's around 14 types of subnetting that we can do on a slash 16 prefix. All right. But if you use slash 17, that means meron ka lang dalawang subnet na pwedeng gawin dyan. And as you can see on the subnet mask, borrowing one on the host portion allows you to have the subnet mask na 255.255.128. So, meaning, you can see from the illustration here, so let me just make some, you can see that we borrowed one here on the network, on the host portion, and it becomes slash 17. Okay? How did it become 2? No, paano nako-compute sir yung 2 na yan? Paano naging dalawang subnet lang yan? Kasi yung isang binaro, that's going to be 2 raised to 1. Okay? And 2 raised to 1 is equal to 2. Therefore, there are 2 subnets that can be created. What about the host? Sa host naman, yung kung ilan yung 0, bilangin mo yung 0, that's around 8 plus 7, that's 15. That's 2 raised to 15. So 2 raised to 15 is 32,766. Alright? So yun naman yung number of hosts. So madedetermine natin dito sa binary format ng network address at host kung ilan ang subnet at kung ilan ang host. Okay? Is it clear to everyone? Malinaw po ba? May question kayo so far sa explanation? Hello? May kausap pa ba ako dito? Parang wala na akong kausap none so far. Thank you, Luis. You're always ready to answer. Thank you sa mga nagre-reply. Okay, so moving on, as I mentioned, mahalaga na ma-interpret natin yung subnet mask into binary kasi dyan natin kukunin kung ilan yung number of subnets para wala ng computation. Ang gagawin mo na lang computation ay ito. Kung ilan yung nabaro na bits at kung ilan yung natirang bits. No? Ito yung natira that will be used for the number of hosts. Yun naman pagbaro ng bits, yun naman yung gagamitin mo for the number of subnets. Example number 2, slash 18. No? So, ang subnet mask ng slash 18 ay 255.255.192. So, bakit siya naging 192? Kasi dalawang bits yung nabaro niya, yung 128 at 64. And if you sum 128 plus 64, that's around 192. Correct? So, dahil dalawa ang nabaro niya, so 2 raised to 2, that's 4. At yung natira naman, 2 raised to 8 plus 6 to 14. 2 raised to 14 is around 16,382. May 384 talaga yan. Minus the broadcast address and the network address. Kaya siya naging 16,382. So, ganun lang kasimple, no? All throughout the rest of the conversion of the slash 16 prefix to other prefixes, makikita natin na kung ilan parami lang ng parami yung binabaro natin na bits, no? Kung mapapansin niyo yung trend, parami lang ng parami yung number of bits na binabaro. So ito naging 3 na, ito naging 4, ito naman naging 5. So kung ilan naman yung natitirang 0, yun naman yung number of hosts minus 2. Okay? So very simple so iwan na natin tong topic na to and we'll proceed with here. Actually ito explanation lang, no? So for example daw, If you have a large enterprise that requires at least 100 subnets and has chosen the private address na /16, no, 172.16.0.0 as the internal network address. So anong slash ang gagamitin mo to get a 100 subnet? So babalikan mo lang tong table na to. So alin dito ang kasya ang 100 subnets? So hindi pwede ang /22 kasi 64 subnets lang 'yan. Hindi rin pwede ang /24 kasi sobrang dami ng subnet, no? Na pwede mo ma-create 256, sobra-sobra 'yan. So ang eksakto doon sa given problem is ito, /23. So therefore, looking at ano ba nangyari? Looking at the scenario na binigay sa atin dito, you can see na yung 7 bits is needed, no, to be borrowed. 7 bits is needed to be borrowed for a total of 128 subnets for a /16. Okay? So that means you need to borrow 7 bits, ito yon, no, in order to satisfy the condition na makapag-subnet ka at least 100 subnet. So sobra yan ng 28 subnet, pero pasok na yung requirement nitong large enterprise na to. So ano na ngayon ang mangyayari? So ano na ngayon ang itsura? So ito yung itsura niya. So magbabaro siya ng 7 bits. So ibig sabihin ang magiging ano mo na ngayon, subnet mask mo is 172.16.0.0/23. Kasi nagborrow ka ng 7 bits para makapag-create ka ng 128 na subnets. Alright? And kung babalikan mo yung table, ang ibig sabihin ng 128 subnets, pwede kang maglagay ng 512 addresses per subnet minus 2 para sa network and broadcast. So, ibig sabihin ang hinahanap palang requirement is bawat subnet ay merong 500 host. At least 100 subnet na merong 500 na host bawat subnet. Alright? So, yun po yung tinutukoy dyan. Ito naman, example, ang requirement naman ito, 1,000 subnets naman ang kailangan using a prefix or a network of /8. Kung napansin niyo yung table ng /8 wala dito, pero pwede nating tingnan yung /8 kung ilan yung pwede nating i-borrow na bit dito sa example na to na ang image na nasa kanan. So remember, the number of subnets that we need is 1,000. Okay? And kukunin natin yan from this address na 10.0.0.0. Ang prefix is /8. So meaning, yung original network niya is ito lang, no? 10.0. So ang original na prefix niya o subnet mask ay 255.0.0.0. So kaya lang ang gagawin natin, kailangan nating mag-subnet nga, no, para magkasya yung 1,000 subnet, no? Ilan beses tayo magsa-subnet. So looking at this, if you borrow one, no? If you borrow one, only 2 subnet lang yung magagawa mo, no? If you borrow 2, that's 4. So that means if you borrow 8 bits, 256 lang, hanggang 256 lang din yung subnet na makikreate mo. But if you borrow 9, 512 subnets. So in order to satisfy the 1,000 subnets, you need to borrow 10 bits, no? You need to borrow 10 bits in order to have 1,024 subnet. So hanggang dito yung ibabaro mo, no? Hanggang dito. Okay? 10 bits ang ibabaro mo. Okay? So that's around 2 raised to 10 or 1,024 subnets. So you need to borrow that. So ano na ngayon ang mangyayari? Kung nag-borrow ka ng 10, okay? So meron kang originally 8, 'di ba? So nag-borrow ka pa ng 10, ano na ngayon ang tanong ko, ano na ngayon ang prefix niya? Anyone? Ano na ngayon ang prefix niya kung nag-borrow ka ng 10? 18? Any other answers? Are you sure na 18 yan? Elvin, can you explain kung bakit naging 18 yan? Kung tama yung sagot mo na 18, explain mo nga kung paano naging 18 yan. Or anyone can explain, no, or justify the answer. Paano naging 18 yung prefix niyan? Okay. So sabi ni Elvin J, 8 po yung nauna tapos nag-borrow pa ng 10. So naging 18 nga, no? Naging /18. Okay? So ano ngayon? Tama 'yon, tama yung sagot mo. So 18 na siya. Ano ngayon ang magiging ano ngayon yung magiging subnet mask ng /18? Ano ang subnet mask ng /18? So that's ano? That's 255. Sige, kayong sumagot. Madali lang yan. 18 lang eh. Di ba? So, meron ka ng 16, 88, di meron ka ng buo na 255, 255. So, aalamin mo na lang yung natitirang dalawa. Sige nga, anong sagot? Okay, mag-participate kayo ha. Ayan. Okay, so bakit mayroong question mark? Hindi sure. Pero tama sagot mo, Cruz, no? Dalawa lang yung nabaro mo sa sa third octet. So that's 128 plus 64, that's 192. Okay? So tama 'yan, no? 255, that 255 plus dalawa pa yung nabaro, that's 192. 'Di ba? So that's correct. So tatandaan nyo yung kung paano kinukuha. At meron namang shortcut, no? You don't need actually hindi mo kailangang i-memorize yung table. Tingnan mo lang yung dito sa binary format, no? Makikita mo na kung ilan yung binaro niya, makikita mo na kaagad yan kung ano yung kanyang mga prefixes at kung ano yung kanyang subnet mask. Okay? So I think there's a video here that will demonstrate creating subnet across multiple octets. So let's try to watch this. I think this is important video. Let me launch the course. Oops. So far, baka may question kayo. Pwede kayo magtanong, guys. Ha? Let me open the course content. I think pagkatapos, hindi pa, no? Pagkatapos pa ng 2 module pa bago kayo mag-online exam uli sa dito sa doon sa NetAcad. Okay? So ito yung video, subnet video, asan na ba yung video na yan? Ito. This video will demonstrate creating subnet across multiple octets. So let me show you the video.
In classless subnetting, we've seen how we can borrow bits from the...
Guys, may sound?
Meron po, sir.
Thank you. So itutuloy ko, ulitin ko lang uli.
in classless subnetting, we've seen how we can borrow bits from the host portion of the subnet mask, and that the last one that's borrowed is the magic number, meaning that the last one, if we look at the place value of the 8-bit grouping, the last one in this case is in the 32's place, so the networks go up by 32. Starting with the 0 network, we have the 32 network, then the 64, 96, 128, so on and so forth, but the networks go up by 32. What about when we're subnetting from a Class A or Class B network address and subnetting generally in the other octets? Let's take a look at another example. This time we have a 10.0.0.0 network address and a classful Class A subnet mask, and we're going to subnet it. So we've taken the 8 bits and borrowed 3 bits, and now we have a /11 subnet mask. The last one in the subnet mask is still in the 32's place. If we look at this 8-bit grouping in this octet right here, the last one is still in the 32's place. So the networks will go up by 32. So the networks are the 10.0, 32, 64, 96, and they're going up by 32, but in the second octet. The only difference is now we have a lot more host addresses. We have 8, 16, 21 zeros for hosts, which means there's over 2 million hosts per subnet. For instance, if we take a look at this 10.192.0.0 subnet, the next subnet is 10.224. So that means that the host addresses go from 0.1 all the way up to 10.223.255.254 as the last usable host, and 255 is the broadcast. The next address is 10.224.0.0, which is the next subnet. All of these subnets are now /11. What about a more difficult scenario? In this scenario, we need to create over 300 equal-sized subnets of 20,000 hosts each, starting from the 10.0.0/8 network. So we need to create a lot more subnets, and we need a lot of hosts. Looking at this situation, we know that we're going to need to borrow bits from the host portion of our subnet mask. The question is, how many bits will we borrow? If we borrow 1 bit, we have 2 subnets. Now we have 4 subnets, 8 subnets, 16, 32, 64, 128, 256, 512. If we borrow 9 bits, we'll have 512 subnets that we create, and that will be sufficient to meet the demand for 300 equal-sized subnets. What about the requirement of 20,000 hosts each? We have 15 zeros left for hosts per subnet. 2 to the 15th power is 32,768 minus 2 would be 32,766 hosts per subnet. That meets the requirement of having at least 20,000 hosts in each subnet. So this scenario would work. You can see here that I've now highlighted the borrowed bits from the subnet mask. I've also converted it to decimal here, 255.255.128.0. And I've already ascertained that the last one in the subnet mask is in the 128's place, so the magic number is 128. The subnets will still go up by 128, but they'll also need to go up for every number possible in the second octet. If we look below here, we can see our subnets. The first subnet will be the 10.0.0.0/17 subnet, then the 0.128 subnet, then the 1.0 subnet, then the 1.128 subnet. And as you can see, we're iterating through every possible number in the second octet and then going up by 128 in the third octet. If I was to list out every possible subnet, we'd go all the way up to 10.255.0.0, and the next subnet would be 10.255.128.0. /17 is our last subnet, for a total of 512 subnets. In a situation like this, there's many more subnets and many more hosts per subnet, but the rule of the magic number still applies.
Okay, so remember those tips no from this video. This is very important. The use of magic number, kahit anong uh, kahit anong subnet pa or kahit anong type of IP addresses yung ibinigay sa inyo, like for example class A, mapa class A man yan, mapa class B or class C, the rule of the magic number still applies. And what is the magic number that we have learned from here? That's the last bit, no, yung pinaka least significant bit, yung last bit doon sa ating borrowed bits. So it can be depende kung ano yung nakatapat na borrowed bits, no. So as we see from there, so we can use that as a tool para mapadali yung computation natin, no? Rather than using a lot of tedious computations. Pwede natin gamitin yung mga tips na yun na kino-cover dito. So you can see they found a way, kasi before nung nag-aaral ako ng Cisco dati, alam ba ninyo na hindi pa kino-cover ito. Mano-mano ang computation namin ng ano. Tsaka walang mga ganun na magic number, no. Ngayon na lang na later na lang yan, siguro mga uh, uh, 5 years ago na nauso yung mga magic number na dinidiscuss, because they found a way to illustrate how to simply uh, compute, no, for the number of hosts, and at the same time the number of subnets that can be used, no, in any given case, not only in a class C subnet but as well as in class B and class A. And then there's a lab here for calculating the IP version for subnets. And in this lab, you will complete the following objectives. I think this is to determine the IP version for address subnetting and calculate the IP version for address subnetting. Okay. I don't think na pinagawa ko sa inyo yan. Let me just see. I think the last activity is to calculate the IPv4 subnets, no, 11.2 yung pinasubmit ko sa inyo. And I haven't checked it yet, but as you can see, some of the assignments were already checked. I have the time to check it. And module 11 yun, ano. Aside from that, isa lang yung pinagawa ko, 11.2 lang. Okay, so I'm not gonna give you an activity this week, but you will have a skills exam on Friday. Okay, and that is going to be a timed exam. Okay, so you'll start having the exam at 10:30 in the morning and you'll be finishing at 1:30 in the afternoon. Okay, so gagawin nyo po yan ng 3 hours lang, because that's an exam, a skills exam. Okay. Okay, how to subnet to meet the requirements. So this is the 7th part of the module. You can see here that private and public IP version for address space are compared here. And as you can see that in a particular enterprise network, you have an intranet and a DMZ. So what is an intranet? An intranet is a company's internal network, typically using private IP version for addresses. So yung common lang na private IP addresses, ginagamit yan sa intranet. For a DMZ or a demilitarized zone, a company's internet-facing server, devices in the DMZ use public IP version for address. So makikita nyo rito sa illustration na kung ikaw ay merong intranet, ang gamit mo ay private IP version for address. Pero pagka DMC o demilitarized zone, remember this is your ISP, no? And this is the internet. So kung merong ang DMC, some companies have that, no? They use a public IP version 4 address. So ibig sabihin may kanya-kanyang public address yung mga server na yan sa DMZ. Now a company could use the 10.0.0.0/8 and subnet it using /16 or 24 network boundary. The DMC devices would have to be configured with public IP addresses, no? In that case. Now, to minimize the unused host IP version 4 addresses and maximize the subnets, there are two considerations when planning the subnet. The first consideration is alamin mo muna kung ilan ang host address na required sa bawat network. So that's the first requirement, no? So hindi ka nagsa-subnet ng kursunada mo lang o kung ano lang yung gusto mo. Alright? So you need to determine the number of host address na talagang required for each network. And sometimes iba-iba ang need, no? Hindi siya pare-parehong 126, hindi siya pare-parehong 62, 30, minsan variable. No, kaya mamaya aaralin natin yung variable length subnet masking. Kasi sa bawat subnet, iba-iba yung requirement ng number of hosts na kailangan. Another consideration is yung ilan ba yung subnet na kailangan mo, no? Ilan yung subnet at yung pangalawa, ilan yung host address na kailangan sa bawat subnet. Okay, that's important. Remember this, if you have a /25, meron kang dalawang subnet na pwedeng ma-create and this is the number of hosts na pwede mong gawin sa bawat subnet. Okay? And so on, okay? All right? So that's the two considerations that are needed. Now, this is an example of an efficient IP version 4 subnetting. And in this example, we have a corporate headquarter and that it has been given a public network address of 172.16.0.0/22. So kung /22 yan, ang kanyang network address ito yung kanyang network address, di ba? Ano yung kanyang kung /22 ito guys, ilan yung kanyang borrowed bits? So meron tayong 8 plus 8 10, di ba? So /22, meron tayong 6 borrowed bits dito. And kung meron tayong 16 borrowed bits, ano ngayon ang kanyang prefix? Ano ngayon ang kanyang prefix? So, ang kanyang prefix ay anyone? Ano yung prefix niya o ano yung subnet mask ng /22? Remember, it can provide 1022 host address, no? Accordingly. But here, in this example, there are 5 sites ng company na to, itong corporate headquarter na to, and therefore 5 internet connection, which means the organization requires 10 subnets with the largest number that requires 40 addresses or 40 hosts. Okay? So it allocated 10 subnets. So kailangan niya ng 10 subnets. Kung 10 subnets, kailangan niya ng /26. So kasi dito, mapapansin nyo na kung 10 subnets, kung babalikan natin to sa /26, ay nagsimula nga pala siya sa /22. Kung /22, ito kasi yung network portion niya, 'di ba? /22. So you can see here that we have 10 host bits dito sa kanyang host portion, no? Meron siyang 10 host bits kasi yung sa network portion niya, meron pa siyang nahiram na 6 bits dito to make it 22. May natira ngayon na unborrowed bits para sa host portion na 2 plus 8, that's going to be 10. And that is equivalent to how many hosts? 1022 hosts. So ganyan yung ano. Kaya tinatanong ko sa inyo, ano yung kanyang subnet mask kung ano yung kanyang subnet mask kung /22. Okay? So basically, hinati siya into 5, no, accordingly dito sa ano natin sa illustration dito, and you can see na ginamit niya yung /26, no? Kasi yung /26, it will give us 10 subnets. All right? So how do we explain this? So you can see from here, okay, wala na palang explanation dito. So you can see that the only requirement here is we need for at least 40 public address, no, as the largest requirement, no, for each subnet. And as you can see na although lahat sila iba-iba yung requirement, no, for example yung corporate headquarters need niya ng 40 address, yung branch 1 25 lang, yung branch 2 is 30, yung branch 3 is 10, and then the branch 4 is equal to 15 public IP addresses. Okay? So you will notice na yung pagkakahati-hati is in a /26 subnet. Okay? So nung sinubnet natin to, itong host portion natin, ginawa natin /26. /26 is magmagaano pa tayo dito, no? /26 ibig sabihin ang ibabaro natin bits dito ay 2 sa last octet. So therefore, that's around makikita nyo rito yung remaining bits natin is 2 raised to 6. And 2 raised to 6 is around 64. Tama? 2 raised to 6 is 64. Therefore, pasok na pasok yung 40 addresses doon sa largest subnet natin. Kaya /26, 64 yung kanyang interval din, no? No, makikita nyo that 64 yung interval, no? Yan. Na makikita nyo yung unang network is 172.1.16.0.64 as the first subnet. Okay? And then it is followed by the other branches, no? Yung makikita niyo yung pagkakahati-hati na network, ito yung unang binigyan. The second one is this one. Ay, no. This one is the second one pala. Ang liit kasi, hindi ko makita. 0.128. Yan. 0.128 is the second network. And the third network is this one, no? Yung branch 2. And then ito yung address ng branch 3, 1.128. So mapapansin nyo ang kanyang interval is .128, no? 128 yung interval niya. Okay? So because that's around 128. So we also have a packet tracer activity here. No, these are all recommendations, no, since hindi naman natin ipe-perform, hindi naman required na i-submit nyo. I suggest na if you have some time, you do the activity para malay nyo, ito yung kasama sa exam, di ba? So, yun yung maging practice nyo. I think this is the last topic for today. This is the VLSM or the variable length subnet mask, no? So we have a video to explain the basics of VLSM here. I'm gonna show you. So here's a video. Okay, let's watch it. Around 2
The
minutes.
basics of VLSM, or variable length subnet masks, works like this. 1. Subnets do not have to be equal sizes, as long as their address ranges do not overlap. So we can create unequal sized subnets. They do not all have to be the same size. 2. When creating subnets, it is easier to work from larger to smaller subnets. So for example, I have the 192.168.1.0/24 network. I subnet the network into 4 subnets /26 subnet masks. So the subnets go up by 64. I now have 4 equal sized subnets. With VLSM, or variable length subnet masks, I can decide that I want to change one of these subnets and further subdivide them into smaller subnets, as long as the address spaces that I create, or the subnets that I create, do not intrude into the other subnets. For instance, I could take this 192.168.1.192 subnet. The address range for this subnet goes from 192 all the way up to 255. What I can do is I can say, instead of having this subnet /26, what if I take that address space and divide it into 2 smaller subnets, size /27 each? If I do this, I effectively have created 5 subnets. The 3 subnets up here are 64 hosts each, and the 2 new subnets that I created from the 4th subnet are 32 hosts each. The reason I can do this is because my 2 smaller subnets do not intrude into the larger subnets. This is variable length subnet masks. In this situation, it has also allowed me to create 5 subnets, thus escaping the equal sized subnet limitation of creating subnets in powers of 2. This gives me greater flexibility and allows me to create subnets of different sizes based on the requirements of my network.
So, yan po yung example, yung definition ng variable length subnet masking. No? It allows us to basically divide our network. The number one condition is that dapat hindi nag-overlap yung mga address kapag dinidivide natin siya. Okay? Remember that we can do that. And it's very, another rule is that kailangan from the larger to smaller yung gagawin natin, larger to smaller yung gagawin natin variable length masking. So we have an example of this variable length subnet masking. No? This video will demonstrate creating subnet specific to the needs of the network. So merong mga scenario dito na ipapakita sa atin, and let's watch it. Right? This is around 10 minutes.
In this scenario, the task is to subnet the 172.16.0.0/23 network to create the following subnets: 1 network for 200 hosts, 1 network for 100 hosts, 1 network for 50 hosts, 1 network for 25 hosts, 1 network for 10 hosts, and 4 point-to-point networks for 2 hosts each. Before I begin to create these subnets, I need to check to see if I even have enough addresses in this address space to create all of these subnets. So by writing out the network and the subnet mask in binary, we see that we have a /23 subnet mask. Here's 23 ones in binary. The last bit is in the 2's place. If we look at this 8-bit grouping in the 3rd octet, we see that the last one is in the 2's place. That means the subnets would go up by 2. So the next subnet will be 172.16.2.0/23. So the address space that we're working with goes from 172.16.0.0 all the way up to 1.255. Let's see if this is enough addresses to create all of these subnets for this specified amount of hosts. I can see that starting from a /23 subnet mask, we have 9 host bits. So effectively, there's 512 hosts. If we look at each one of these subnets that we're going to need to create, I cannot create a 200 host subnet, but I can create a subnet for 256 hosts. That number does not reflect the usable hosts, but the total number of addresses in the subnet. Similarly, I'm unable to create exactly a 100 host subnet, but I can create a 128 host subnet, a 64 subnet, a 32 subnet, a 16 subnet, and 4 host subnets will satisfy these requirements. If I add up all of these numbers, 256, 128, 64, 32, 16, and 4 subnets of 4, the total number is 512. So I'll have exactly enough host addresses to create these sized subnets and meet the requirements. Once again, these numbers here for the subnet sizes that we'll create do not reflect the usable host addresses, but the total number of addresses in the host portion of the subnet ranges, including the network address and the broadcast address. So let's get started subnetting this network using VLSM, variable length subnet masks, and working from largest subnets to smallest subnets in order to create all of the subnets required. So working from largest to smallest, the first thing I need to do is to create a network for 256 hosts to satisfy the 200 host requirement. What I can do is I can subdivide this single network of 512 hosts into 2 smaller subnets of 256 hosts each. So instead of having a 172.16.0.0 network /23, change the subnet mask to /24. This creates 2 networks 0.0 and 1.0, each subnet having 256 or 8 host bits. Notice how the subnet mask has changed from /23 to /24, and I now have 2 256 host subnets. What I can now do is keep the first of these subnets and subdivide the second one. To do this, I simply take this 172.16.1.0/24 subnet and change it from /24 to /25. So now I have the 172.16.1.0/25 subnet. This creates another subnet, 172.16.1.128. Both subnets have a magic number of 128, meaning the networks go up by 128. So I've taken this one network of 256 hosts and subdivided it into 2 networks of 128 hosts each. Now I have a subnet to meet this second requirement. Moving on from there, I'll keep the first of these subnets and then further subdivide the second one. So now we no longer have the 1.0 network in its place. We have the 1.0 subnet and the 1.128 subnet. Then I subdivide the 128 subnet into 2 smaller subnets /26 each. So now there's no longer a 128 subnet. There's 2 subnets in its place, a 128 subnet and a 192 subnet. Both of these subnets have a /26 subnet mask. If I was to write this subnet mask in the binary conversion table here, we would see that in the 4th octet, /26 means that the last one in the subnet mask is in the 64's place, and the networks go up by 64. Furthermore, with the /26 subnet mask, you only have 1, 2, 3, 4, 5, 6 host bits, and 2 to the 6 power is 64, meaning there's 64 hosts, 62 usable per subnet. I now have my 256 host subnet, I have my 128 host subnet, and my 64 host subnet. I can subdivide the second of these two subnets into two smaller subnets of 32 hosts each. To do this, I take the 192 subnet and subdivide it by changing the set mask from /26 to /27, creating two subnets of 32 hosts each. So now I'm no longer using the 192 subnet /26. I'm using it as a 192 /27 subnet and a 224 /27 subnet. From here, I still need a subnet for 10 hosts. I can take the second of these two subnets for 32 hosts and subdivide them to two 16-host subnets. To do this, we take the 224 /27 subnet, change the subnet mask from /27 to /28, and now I have two smaller subnets. From here, I take the second of these two 16-host subnets. I only need one. The second one I'll use for four subnets of 4 hosts each. So now instead of the 240/28 subnet, I have the 240/30, the 244/30, the 248/30, and the 252/30 subnets. Looking at the subnets that have been left, we have the 172.16.0.0/24 subnet. This is good for 256 hosts. We have the 172.16.1.0/25 subnet. This is good for 128 hosts. The 172.16.1.128 subnet /26 is good for 64 hosts. And the 192/27 subnet is good for 32 hosts. The 224/28 is a 16-host subnet. And then the last four subnets /30 each, 240, 244, 248, and 252 are good for 4 hosts each. Once again, these sizes do not reflect the usable hosts in each subnet, but the total number of addresses in the host portion. For usable host addresses, you need to -2 from each subnet. If we examine the host addresses closely, we'll see that none of the subnets overlap. In other words, this 172.16.0 subnet goes from 0 all the way up, since it's /24, to 255. You can see that the next subnet starts at 172.16.1.0, so the two subnets do not overlap. Similarly, this second subnet goes from 0 to 127, and we can see that from host 0 to 127, the next subnet at 172.16.1.128/26, that there's no overlap. This subnet ends at 127, the next subnet begins at 128, and so on and so forth. In the end, we've created 9 subnets of different sizes: a 256, a 128, a 64, a 32, a 16, and 4 4-host subnets. This is Vlsm, and it allows us to create subnets or networks specific to the needs of the network.
I hope you understand the video. It's very basics of how it was explained. So, however, the requirement that was asked on the video was only designed for not for usable host address, no, but for all the available host that is needed per subnet, no. Like in the case, kailangan niya ng 128 na host, 64 na host, 16 and 8 hosts, and then apat na 4 hosts per address. So that doesn't require iba kasi yung requirement. Halimbawa, mayroon kayo na encounter na ang kailangan yung bigyan ng host ay ganito. Ibig sabihin, you're counting the number of usable host address. And that's going to be different. Kasi yung binigay na example dito sa video is counting it's counting the number of hosts per network or per subnetwork. Okay? And you'll notice na pinakamadaling paraan para magawa yan is to start from the largest requirement down to the least requirement. Okay? So any questions po regarding the variable length submasking? Napakadali lang yan, ha? I hope na if in case na nalilito kayo, ulit-ulitin nyo lang yung video because napakadali talaga niya. No? Halimbawa, the first network, hahatiin mo lang sa dalawa. The second network, hahatiin mo ulit sa dalawa. No? And you're going to use the second subnetwork to divide it again by 2, no? And then hanggang sa ma-divide mo yan by 4 because that's the last network that you can have. Okay? The essence of that is, the essence of variable length subnet masking is about address conservation. Okay? So meaning na ko-conserve natin ang paggamit at walang masyadong nasasayang na IP addresses. No? Especially if the subnetworks have different requirements from one another. Like in this case, building A needs 25 hosts, building B needs 20 hosts, building C needs 15 hosts, and building D needs 28 hosts. No? On the other hand, meron pa tayong network dito na kailangan lagyan natin ng 2 hosts each, no? Yung connection between R1 and R2, between R2 and R3, and between R3 and R4. Okay? Now, given here is a /27 mask that would provide 8 subnets of 30 host IP addresses, no? And therefore support this topology. So lahat sila kasya yung 30 host. Okay? Lahat sila kasya yung 30 host, no? So yung 15, 30 host, hindi pwede rito ang /28 kasi yung /28, 14 host lang yung pwede nating ilagay, no? -2. Dito on the other hand, /27 is the correct format because we still need the 2 hosts each. Actually, pwede na dito ang /30, but you will notice na may mga nasasayang dito sa slash o prefix na ginamit na /27. Dapat talaga dito, ang ginagamit lang dito ay /30. Okay? Pero napansin niyo, kung 30 dito, 30 dito, 30 dito, okay lang, no? Kasi depende yan sa need na host. Pero dito, 2 host lang ang kailangan. So, sobrang dami ng nasasayang dito na address. Okay? Kaya, ayan, sabi dito, the point-to-point one lengths only require 2 addresses and therefore it weighs around 28 addresses each for a total of 84 unused addresses. Kaya siya unused kasi hindi na siya magagamit. Dalawa lang yung pwede mo, hindi mo pwedeng ibigay yung iba dito kasi different network na to, no? Yung R1 and R2 is one network, R2 and R3 is a different network. You cannot put, no, or you cannot make sorry. Sorry. You cannot make an overlapping addresses. Okay? Kaya nasasayang. So you need to apply yung traditional na subnetting scheme. It's not very efficient, no, because a lot of wastage nga on the part of the computation of the IP addresses. However, Vlsm was developed to avoid wasting addresses by enabling us to subnet a subnet. Okay? Kaya subnetting a subnet is a different term. So that means parang yung pizza, no? Kung halimbawa ito yung pizza mo, the pizza can be divided into how many subnets? 30, no? 30 hosts yung kailangan mo. So you can divide one subnet and that can be divided into around 8 smaller subnets of 2 hosts each. So yan yung dinescribe dito. So walang problema dito, walang nasayang. Okay? Actually, may nasasayang pa dito kasi meron pa ritong 3 subnet na hindi magagamit, no? Pero pwede mong gamitin yan for future use, no? Actually, hindi yan sayang. Ang sayang, yung lagyan mo ng ito dapat yung masasayang, no? Ito dapat yung masasayang. Pero ito yung magagamit mo for future use because ang ginawa natin dito sa subnet na to, dinivide natin siya into a subnet that can give us ito yung /30, 2 hosts per subnet. Okay? 2 usable hosts. So that's what variable length submasking can do. Okay? Yung exam na gagawin nyo, meron kayong iba-iba ang solution na gagawin nyo. Iba-iba. Kasi depende sa class number nyo. Kaya may makikita kayo doon CN. CN is for the class number. So, ilalagay ko yung class number nyo. So, makikita nyo naman yung class number nyo, di ba? For example, 172.16 that class number, kung ano yung class number mo, halimbawa, ikaw yung unang estudyante, D1, that's 0. 1.0. So that's the first student. The second student, 2.0 naman. Third student, 3.0. Okay, and so on. Okay? Hindi naman kayo aabot ng 255, kaya okay lang yan. Diba? This is an example of a topology for Vlsm address assignment. No? So using Vlsm subnets, yung requirement ng inter-router network can be addressed without unnecessary waste. No? As shown here, mapapansin mo na /30 ginamit dito kasi 2 hosts lang yung gamit. No? So ito yung topology nito ng network na unang binigay sa atin. Ayan. Yung network topology niya, hindi nasasayang kasi gumamit tayo ng /30 in between inter-router network. However, dito sa loob ng network sa bawat isa /27 or 30 host, no, yung kailangan. So, pasok na pasok yung number of hosts na given dito doon sa 30 hosts per subnet. Okay? Structure design. So, IP network planning is crucial and is very important to develop a scalable solution to an enterprise network. So, as a network associate, no, you can be a technician sa isang network and you will be tasked to provide a wide addressing scheme. No? So you need to know how many subnets are needed, how many hosts are. Ito yung dalawang requirement no? How many subnets ang kailangan? How many hosts ang kailangan sa bawat subnet, no? Ano-ano ang mga devices na kailangan dun sa subnet na yon, no? And which part of your network will use the private and which one will use the public, no? Yung mga DMC na tinatawag or intranet. So you need to examine the needs of your organization's network usage and how the subject will be structured. And as you can see here, you have to calculate the network requirement, no, by looking at the entire network to determine how much area will be segmented. Next thing, determine how many subnets are needed and how many hosts per subnet, yung two requirements. And you need to determine also the DHCP address pools, no, kasi siya yung kung ilan yung number of hosts na ibibigay mo at saka kung ano yung subnet mas nagagamitin, yun yung ibibigay na address doon sa address pool mo no? So importante 'yan. Okay? So within the network there are different types of devices that require addresses, no? Meron tayong pang-client, no, yung pang-host, karaniwan 'yan. So pwede mo nang ibigay 'yan using DHCP or DHCP version 6 kung IP version 6 ang gamit mo. Sa mga server at saka peripherals, dapat static ang IP address na ibibigay mo. Okay? Pag mga servers naman na accessible ng internet, usually public IP version 4 address ang binibigay diyan, no? Sa mga intermediary devices naman, gaya ng mga switch at saka routers, in between the networks, devices are assigned addresses for network management, monitoring, and security. Okay? So basically, mga static din to. And of course, we have the gateway para sa connection natin sa internet, no? At saka sa mga firewall devices natin. So kapag nagde-develop tayo ng IP addressing scheme, recommended that we have a set pattern of how addresses are allocated to each type of device. No? So wag muna kayong mag-focus kung paano nyo kukumputin, alamin nyo muna yung need. Okay? So we have a practice dito. So ito yung pag-practicean nyo para sa exam nyo, no? Kasi dito may Vlsm design and may implementation dito. So ang isasubmit nyo sa exam ay document. Usually document ang pinapasubmit ko. Magke-create kayo ng subnetting, so kailangan ko ng table, no? Yung ibang nagpasa sa akin ng exam sa Cisco 1 last time, ang baba ng score. Bakit? Eh, may topology, wala namang IP addressing. Eh, yun nga ang gusto kong makita, yung IP addressing na table. Kung ano yung binigay mong mga addresses, subnet mask o prefix, at saka yung uh, host portion, no? Ibig sabihin yung usable host address, yung range, importante 'yon. Okay? And then of course, dahil merong tayong packet tracer na pwedeng gamitin, no, in creating the, kasi meron aside from the BLSM na gagawin nyo o subnet masking, meron pa rin kayong i-configure na mga router o may i-configure kayo router doon, kaya kailangan nyo pa rin ng packet tracer. So gagawa kayo ng sarili nyong topology. Okay, so lahat ng screenshots na kailangan, need nyong ilagay doon sa documentation. Okay? So yun yung magiging midterm exam po ninyo. So sinasabi ko na sa inyo para may idea kayo kung ano yung laman ng midterm exam nyo. So this is the summary of what we learned from module 11. Okay? So I think there are also some practice dito. So if I were you, pagpa-practicean ko tong mga to, no, tong design and implement a BLSM addressing scheme, kasi medyo hawig dito yung exam. Ganon din ito, no? Design and implement a variable length subnet masking addressing scheme. So here are the things that we learned from this topic, no? Module 11, medyo mahaba siya, 2 linggo natin diniscuss. So we talk about the IP addressing structure, and then the different types of addresses or IP addresses that we can create. And then we talk about the prefix, no, which is used to determine the host and the network address, as well as the number of hosts that we can give kapag nagsasubnet na tayo. And then we did the subnetting and then the variable length subnet masking, which is used to create and conserve IP addresses, no, much preferable type of subnetting a network. So if you have some questions po related to the topic na diniscuss natin, baka meron pa kayong hindi naintindihan, kindly ask or type your question in our public chat para matugunan natin yung inyong mga questions. So, final call for the attendance, Barilea, absent na naman, no? Barilea, ito, malamang to, idadrop ko to eh. Sobra-sobra na absent nito, no? Pati sa prelim tsaka midterm niya, hindi sila pumapasok. Although nagsasubmit, pero hindi sapat ang submission ng requirement sa akin. Mahalaga sa akin ang attendance. And TIP also, pinapahalagahan yung attendance na yan. At pwede kaming mag-drop ng student na remember, nagpa-ano na ako sa inyo nung prelim sa di ba? So, pwede ko na kayong i-drop kung sakali. Fernando, absent. Gayoso, Labadan, Makamus, late to. Peligaria, dumating ba? Hindi. Paruginog, Hindi ko alam kung anong oras ka dumating kasi wala ka yatang tinype dito. Nag-type ka ba kung kailan ka dumating? Anong oras ka dumating? Kasi nag-check ako ng attendance kanina, wala ka pa. O absent ka. Sorry. Ha? Lagi niyong tatandaan ang responsibilidad nyo. Hindi pwedeng basta na lang kayo darating nang hindi kayo nagsasabi, lalo na kung late kayo. While checking the attendance, walang problema. Chine-check ko yan talaga. Pero kapag nagle-lecture na ako, I don't have the skill to do two things at the same time. No? Hindi ko kayo pwedeng checka ng attendance while I'm discussing the lesson. Okay? Lalo na yan. Sinabihan ko na kayo, pagka late kayo dumating, mag-type kayo kung kailan kayo, anong oras kayo dumating. No? Malalagay naman dyan yung timestamp nyo kung sakali. Okay? O, pasensyahan ha. Sino pa to? Santos. Santos, hindi ko rin alam. 10:38 daw. Tingnan natin kung 10:38 ka dito. Nag-type ka ba? Ayun, okay. Nagsabi niya, good morning sir. Sorry, hirap po makapasok sa BBB. So, late ka. Hindi ka absent. Yun lang. Any questions po? I am posing